Geometry, representing and describing transformations. So a transformation is a function that changes the position, shape, and or size of a figure. Any combination of the three is a transformation. The figure that is used as an input of transformation is called the pre-image, right? And the output, the result, is called the image. So let's say you have a translation, reflections, and rotations. I'd like three types of transformations, and the decorative tiles shown to the right is all three types of transformations, as you could see, right? Essentially, for example, if you have a line over here, guys, this could be a reflection this way, right? If you had rotated this 90 degrees, it will look exactly the same. Or you could have said that individual ones has been translated to the right, or this to this would have been translated right and then up. So depending on how you define it, individual tiles can be seen as a translation, reflection, or rotation. Or if you want to look at the single, for example, single tile like this, guys, right? It could be reflected sideways this way. Or if you rotated that 90 degrees, it will look the same. So there are multiple ways of looking at this. Let's say we have a point A. If that's a pre-image, you could slide that right then up, and that'll be translation. And the resulting point right here is called an image, and we usually denote that with a prime. So harkening back to algebra 1, right? How do I do this? So we have a rule here. If you have your input is x and y, your input being the pre-image right there. That's the pre-image coordinates. That would be the image coordinates. And usually that's denoted by the transformation, that is an arrow. Okay, so that's the rule. So this is the rule to get the image. So a prime, if we apply the rule, will be whatever the x is, minus 4, whatever the y is, minus 3, and the y happens to be 4. And then a prime now becomes negative 4, 1. Similarly, once again, it is whatever the x is minus 4, whatever the y is minus 3. I could even just make a copy of that like this, guys. Paste it like that. And all I do is copy these values respectively to each side, right? X is a 3, y is a 0. Next one is a 0, 0. So the B prime results in negative 1 and negative 3. C prime results in negative 4 and negative 3. Let's see what happens when I graph that. Okay. Let's just that point right there. Negative 4, 1. Negative 4, 1 is right there. And B is negative 1, negative 3. Negative 1, negative 3 is right there. And C is negative 4, negative 3, which is a negative 4 or negative 3. I believe it's right there. So that would be A prime, B prime, and a C prime. So if I connect them, let's say, it will be from here to here, here to here, and here to here. And what I see over here is this should be a transformation. And did I just make a mistake? Let me just double check. Yes, I did. Because immediately, if you sort of think about it, this is translation, which means the shape should not change, should it? And clearly it looks different. And the mistake was that that was negative 1, but I put in the positive 1. Y'all see that? So what I'm going to do is erase these two, and I'm going to move that to this part right there, guys. And now let me connect it. And this should look like the same shape. From here, here, and here, all that happened was I actually, according to the rule, moved left 4, then down 3. So it went like this, right? And all three of them should have moved the same. And that vector right here that I just drew, C to C prime, B to B prime, A to A prime, should be all parallel. Okay? Good. All right, so that's how you would check. Now, if you look at this particular one over here, you're doubling the x, so you're not moving stuff. You are making something bigger, so generally you would not expect it to be the same shape. All right, guys, pause a moment and take your best shot. Okay, I'm going to assume that you finished working on it. And the answer, as it turns out, I just put a key there just in case I make a mistake. There you go. Going through this, the rule is that we just simply double the x value. So, as you could tell, I just put 2 to 2 right there. I doubling all the x values right there, right? And when I did that, the height remained the same from here to here, but the width, that got a little wider, right? So yeah, so it was stretched sideways and it was twice as big. So that was it. Okay, moving on. So I'm going to be describing a rigid motion, right? So what's going on here? All right. So what is exactly a rigid motion? Okay, rigid motion or isometry is a transformation that changes the position of a figure. The key word here, guys, is that without changing the size or the shape. That's really, really important, right? Okay. And then following things: translation, reflection, rotations are all rigid motions. So you should make a note of that. 1, 2, 3 items are rigid motions. So if you could show that a transformation is one of the 3 types, translation, reflections, or rotations, then you can say that it's a rigid motion. Because we stated it, you could almost treat this like a theorem. Actually, it is a theorem, okay? Even the book doesn't say so. Okay, so in this particular example, the direction is that they want you to write the rule that each pre-image to its image, then identify the transformation, then confirm it preserves length and the angle measure. Okay, guys? And that's what we're going to do right now. Okay, so let me just zoom in a little bit, okay, so I can see that a little better. The first thing, so I see 1 here, I see 1 here, 4 and 4, 3 and 3. So what I see that the y coordinate of the image is the x coordinate of the pre-image. So I'm going to make a little note of that. The y coordinate of the image, oopsie, is the same as x. So when I say x and y, we are operating on the assumption that that is the pre-image or the original value. Okay, so these are xy's. Okay, now let's look at the x coordinate of the image. I see -2. Well, I see 2 here. Okay, I see -2. I see 2 here. I see 2. I see -2 here. Oh, okay. So what I notice is that the x coordinate of the image is the opposite of the y value. So that's the rule. Okay, part 2 is asking, identify the transformation. So what is the transformation? So I'm going to restate this. So what's happening is xy has become, let's see, so x becomes negative y, and y becomes the x. Okay, that's what it says, right? X becomes, so the x coordinate right here of the image is the opposite of the y, this one. And this second part is always the y coordinate, is the same as the x. Okay, so that's basically what that was. Let me change that to style, make it green, and let's change the right to green. The second part. So what does that exactly mean? I'm going to tell you that this is a 90-degree rotation. And the reason why I can tell you that is without having to draw a new picture. Take a look at this, guys. In this particular example, what we have is we got 1, 2, 3, 4, 1, 2. And then we got 1, 2, 3, 4, 1, 2. So this is demonstrating the transformation that we have. And if you draw a straight line over here, guys, 1, 2, 3, 4, 1, 2, and then this, you recognize that this is 90 degrees, right? This slope over here is 2 over 4. And the slope over here is negative 4 over 2. And they're negative reciprocal of each other, which means they are perpendicular. Hence, they're 90 degrees. So to go from here to here, we're 90 degrees counterclockwise, right? So we could say that this is 90 degrees CCW, meaning counterclockwise. All right, guys. Let's move on. Number 3, confirm that it preserves the length and the angle measure. Well, you know what? We're going to sort of like defer that for later, right? We're just going to go with the fact that it preserves the length. Then if it does so, side, side, side triangle, then all the angles therefore must be the same. Okay? So we're going to defer to that fact. Okay? Number 3. Because beyond that, we're going to have to know a little bit of trigonometry. Okay? And we're not there yet. Number 3. Let's talk about AB. Okay? You can physically see the space, right? And even here, you could tell the y values are the same, right? Because of that, you just have to count the x values. 1, 2, 3. So for something like a vertical or horizontal line, I don't really need you to show me the Pythagorean theorem or the distance formula. Just count. So AB is equal to 3, and A prime, B prime, same thing. 1, 2, 3. How about we have BC? So we're going to have a square root of, let's count this, BC. In this particular case, we got a right triangle. And I talked about this before, right? When I have that over here, you got 1, 2, 3, 4. That distance is 4. And this is 1, right? So what you could do is, instead of doing the math, you could just count 1, 2, 3, 4. Well, so instead of doing a lot of unnecessary arithmetic, so the change in y over here in this case is the 4 squared, and change of x is 1, so that's 1 squared, which yields 16 plus 1 is root 17, right? Good. Let me pull this out a little bit. Okay. All right, so let's go to CA. What is that equal to? CA is this. So if you look over here, that's 90 degrees. 1, 2, 2. 1, 2, 3, 4. 4. Okay, so using the formula, that is, sorry, let me just keep that in the picture, okay? 4 squared plus 2 squared, so that's 16 plus 4, which is root 20. Now, we should simplify this, or we should be able to simplify this, but for now, for the sake of comparison, we're not stating what the exact answer is. We're more interested in the fact that is it the same length. So let's just leave it like that. So we have, what is B prime C prime? If you look at the B prime C prime, I'm not going to draw that one, but it's here, guys, right? Same thing. 1, 2, 3, 4, and then we got from here to here is 1. So you go through the same exact process as 4 squared plus 1 squared, which is root 17. Voila, they're the same. These two are the same. How about C prime A prime? If you look at the shape over here, right, you make a right triangle. So that is 1, 2, 3, 4 this way. And vertically, it's 1, 2. So it's 4 and a 2, right? So it's 4 squared plus 2 squared. And we know it's root 20. That both root 20. CA and the C prime A prime. So yes, the length is preserved. Okay, guys? All right. So we have a your turn. Please pause the video, try this on your own, and if you're successful, you know you got this, right? Okay, guys. I'm going to assume that you have worked on it and you finished. If not, pause right now, okay? So the answer is, the key is this, okay? And you know what? Don't worry about this. I think they were asking you to use a protractor. It's not necessary at this point for us, all right? So don't worry about it. And then I did a little bit more. So you know that square root of 20 is 2 root 5. If you like a real quick review of that, you know that square root of x squared, as long as x is bigger than 0, that is, right? That is just simply x, isn't it? So we like to have a square. So what square divides 20? Is not 4 times 5? By separating that, it becomes this, and this part is equal to 2. So it's 2 root 5. Me personally, I don't like to write all that out. I simply write 4. And right underneath it, I say, hey, this is 4 times 5. And that pops out as a 2. Therefore, it is a 2 root 5. I think it's a little quicker. There's no need for you to write too much. As long as we understand the entire process, we are actually thinking about this as we do that. Okay? Quick, impromptu, sort of built-in review from Algebra 1. All right, guys. So I believe that might be, oops, here we go. How do I do this? Well, we're talking about they're asking us to find the rule, and then confirm that transformation. The keyword here is what? Not rigid. So what that means is that we could show that one point in which the corresponding segment is not the same length, then we don't have to show anything else. We could just stop right there. Okay? So in this particular case, let's get going. So let's examine this a little bit. What's happening with my x? My image in x is 4, and I see 4. That's -2, that's -2, 0, and a 0. Oh my gosh. Nothing is changing. So 1, the xy becomes, x becomes x. Now, let us look at the y values, okay? Now, the y value over here is a 3, and that's a 1. That by itself tells us nothing. And let's look at this over here. That's a -3 and -1. You know what it looks like? We are to go here, we will multiply by 3. And same thing here, we multiply by 3. What is -3 times 3? -9. I think we got the rule. So the y becomes 3y. So we're good. So now they're asking us to show that the, you know what? Let's put JK from here to here. So part 2, I want to know the JK. So if you draw the quick coordinate like this, 1, 2, 3, 4, and 4 and a 1, J is right here, and K is -2 and -1. So it looks like this, right? So what I just look at is, look at the Y values over here. That's difference of 2. Y, the distance between a 1 and -1 is 2, right? And 4 and -2, that's a 6. Okay? So I don't like to do a lot of, 4 minus 2. I think it's kind of unnecessary. If you want to do that, that's fine. So JK squared is 6 squared plus 2 squared, because that length, using Pythagorean theorem, is hypotenuse squared is the sum of the squares of each legs, right? And that gives me 36 plus 4, which is 40. So the JK must be root 40. How about J prime, K prime? Now, if you want to go ahead and graph it, great. You don't have to. You know what? Let's graph it. Might be a good idea. So J is 4, 3. 1, 2, 3, 4. 1, 2, 3. That is J prime. What is K? 1, 2, 3. 1, 2, 3. Negative. That is K right there. So when you draw that picture, ooh, look at the Y values. It goes from 3 to -3. So that must be 6. And visually, it looks about right. And let's look at the X. Ooh, just what I realized? That's 4 and -2. The distance is 6, right? I didn't draw that correctly, did I? Right? It should have been -2 -3, which is here. So JK prime should have been right there. So let me erase the other 2. So you need to catch your own mistakes like this, right? So don't just look at the picture. Don't just look at the number. Try to look at both. So we know that that length is 6. Okay. The fact that they're not exactly the same over here, it's okay. I was just roughing it out, so it could be a little bit off, right? So that is a square root of, if you decide to use the distance formula, we have change in x squared, change in y squared, right? So I'm intentionally doing it slightly differently, because some of you guys prefer one method or the other. It's completely up to you. So that gives you 6 squared plus 6 squared. That is 36 plus 36, which is root 72. Now, because we're not trying to give the exact answer, you don't have to simplify. So if you want, go right ahead. Tell me what it is if you like to. But at this point, I think square root of a number is good enough. Clearly, we could say JK, which is square root of 40, and J prime K prime, which is root 72, clearly they're not equal to each other, right? Therefore, we could say transformation is not rigid. So there it is, guys. All right, it's time for another your turn. So you might want to pause your video. Here it is, guys, and see if you could do this on your own. If you can, you're in great shape. All right, guys. I'm assuming that you have finished already. If not, pause the video again. All right. The correct answer is this. So if you have question on this one, we could go over in class. All right. All right, guys. That is it. Thank you for paying attention, and I'll see you tomorrow. Bye-bye.